In this video, we're going to solve logarithmic equations using the one-to-one property, using the inverse property, and some other properties of exponents and logarithms. In this first example, we have log base 10 of x is equal to 2. I'm going to solve this two different ways. We've seen a problem like this when we first were looking at logarithms. We could rewrite this as an exponential equation. So this is log base 10. So this could be rewritten as 10 to the second power is equal to x, and then we could just evaluate 10 to the second power. That would be 100. So x is equal to 100. Now, another way of doing this, and this is, in this particular case, a little bit of a longer way, but I just want to point this out that this is possible. We could raise both powers, raise both sides to the 10th power, right? And this is called to exponentiate both sides. So if we raise both of these to the power of 10, now over here on the left side, if we have 10 raised to the power of log base 10, those two undo each other. They're like opposite operations. They're inverses of each other. And what we'd be left with is just the x on the left. And then we'd have x is equal to 10 to the second power, and x is equal to 100, again, as we've seen already. Let's go to another example. So we have log base 3 of 5x minus 1, and then that is equal to log base 3 of x plus 7. Here we have the same log base on both sides of the equation. There's just one term, so we could use the one-to-one property, and we could say 5x minus 1 is equal to x plus 7. And then from there, we're just going to solve this, trying to get all our x's on one side. Add 1 to both sides, so we have 4x is equal to 8. Divide both sides by 4. So x is equal to 2. And then we should get in the habit anytime to check our answer in the original. So let's do our check right here. So we have log base 3 of 5 times 2 minus 1 is equal to log times 2 plus 7. So we have log, this should be base 3, log base 3 of 9 is equal to log base 3 of 9, and we're good. And the reason I want to emphasize that you need to check your answers here, because if we substitute x into the original and we were to get, say, a negative number here, we can't, or 0, we can't take the log of 0 or a negative number. So it's important that we check those answers that we get to see if those answers are in the domain of the original equation. Okay, we got a couple more to go. Let's see. So you can see in this equation that we do not have one expression on either side of the equal sign right now. So we cannot use the one-to-one property. Okay, we cannot. This is not equal to 3x plus 14 minus 5 equals 2x. Okay, that is not true. Okay, I want to make sure that you do not use the one-to-one property unless there's one expression on the left and one expression on the right, and they both have the same base. So what we need to do here is use properties of logarithms, and we could rewrite that as 3x plus 14 divided by 5. Okay, that's our quotient property. Now, once you do that, now you could use the one-to-one property. So we have 3x plus 4 divided by 5 equals 2x. I'm going to multiply both sides by 5. So we have 3x plus 4 is equal to 10x. Subtract 3x on both sides. So we got 4 is equal to 7x. So x is equal to 4/7. And then it's important that you Oh, shoot, I just realized something. I was going to say it's important that you go back and check your answer, but before I even do that, I just realized that I made a mistake here. This is supposed to be a 14, not a 4. So let's go in here and change some of this. So that means my answer would end up being 2, not 4/7. So either way, we get an answer of 2, and then you should check. I'm going to leave you to check that answer. And then finally, our last one, we have 2 log base 5 of 3x is equal to 4. So I'm going to use my properties of powers here to rewrite this. So this is log base 5 of 3x squared equals 4. Notice I put that in parentheses. Both of those terms should end up being squared if you're going to use that property going in reverse. So at this point, I could rewrite this as log base 5 of 9x squared is equal to 4. And now, at this point, I am going to exponentiate both sides. I'm going to raise both sides to the 5th power. So that allows me to rewrite this as 9x squared is equal to 5 to the 4th power. So I end up with, if I divide both sides by 9, I end up with x squared is equal to, what's 5 to the 4th power? 5 times 5 is 625 divided by 9. And then I can take the square root of both sides, and we would get x is equal to positive or negative 25/3. But now, it's important that we check, right? We got to check our answers. So if we go ahead and we plug positive 25/3 in here, let's do it right here. So we have 2 log base 5 of 3 times 25/3. Is that equal to 4? And then we're going to do the same thing for negative 25/3. And we can already see, like, we don't have to go ahead with the negative one because we're going to end up taking a log of a negative number, which we can't do. So we're going to have to throw that negative value out. That's not going to be part of our answer. And if we go ahead and we check the positive one, we can quickly see that this is going to end up equaling 4 on both sides. So our final answer should be x is equal to positive 25/3. And that is how we can use the properties of exponents and logarithms along with the one-to-one property and the inverse property to solve logarithmic